Hello. Today we will have a discussion on industrial gas engines RFI suppression. There will be a discussion on RFI and EMI interference and how to decrease it. First of all, we are talking about gas engines for power generation. These are typical applications: gas engine for power generation or gas compressors. So we're not talking about over-the-road cars or trucks. These will be larger engines for industrial use. RFI is radio frequency interference. EMI is electromagnetic interference. Typically, this happens on the high voltage side, as in this photograph, when the red circle on the high tension leads after the coils. So meaning the spark plugs, your high tension leads. A typical 12-cylinder 4-stroke engine that fires 150 times per second, so this is quite frequent. This rapid charging and discharging on the spark plug causing rapid current changes, which would generate an electromagnetic interference around the high voltage side. This electromagnetic field bouncing through the air can cause ionization of the atoms in the molecules it passes through. When these atoms deionize, they release a tremendous amount of radio waves, thus causing radio frequency interference. So, with all that blah blah blah, what are the effects? Digital ignition systems can be affected a lot by the interference, particularly the pickup sensing circuits. As in this drawing from electronic, the pickup signal means a signal that goes to the timing disk. If you have an interference, the pickup signal will be giving you odd signals. So some ignition systems will tell you a system is overspeed, when in fact the engine hasn't been overspeed. It just picked up too many signals, so it thinks it went overspeed. Or it can tell you you have a faulty pickup, where you change pickups, there will be faults, and the pickup, you put in a new one, it still doesn't work. The pickup is perfectly fine, but the signal has been interfered. So be careful when your digital systems tell you overspeed or pickup failure. It may not really be overspeed or pickup failure. It's actually an interference problem. Other electronic controllers and PLCs, meters can also become unstable if you have a lot of interference. So how do you reduce the RFI? The most important method is to be using spark plugs with built-in resistors. This is not a new technology. This technology has been developed in the States in the 1960s, so people have been using it for 60 years plus. So not new tech. Use resistors, plugs. Typical resistance is 3 k-ohms to 6 kilo-ohms, depending on the brand. When you're using a solid state or digital ignition system, always use resistor plugs. What's a digital ignition system or solid state? Anything without a turning magneto, anything that you power it up with a 12-volt signal or a 24-volt DC signal in a box with a circuit board, those are solid state or digital ignitions. You always use the resistor plugs for those kind of ignition systems. And why does this work? Well, the RFI can be transmitted by conduction through wires, or it can be radiating in the air. Now, the resistor in the plug mostly takes care of the conductively transmitted RFI. So if there was RFI or EMI kind of produced in the spark plug, it wants to go through the plug and into your high tension lead. The resistor in the plug would block some of the signals and send it back more to the casing of the plug, which is connected to your engine that goes to ground. So it forces the interference to the engine block instead of to the rest of your system where you don't want it. Other reduction methods, high tension leads like this one with a built-in 5 kilo ohm resistors that would further block the interference when going up into ignition system, blocking it, sending it more back to the casing of your spark plug than into the engine block. What about the radiated part? Well, the radiated part with regards to digital ignition systems, the most sensitive part being effective is, again, the pickup signal. So you want to make sure your pickup signal, the cables are with proper shield cables, and you ground the shield cables according to the manuals properly. For other sensitive equipments, always use shield cables whenever it's required. Proper grounding of the ignition system is important to reduce RFI. It is extremely important for the stability and the reliability of the ignition and to reduce the RFI. You have proper grounding. First recommendation always is to read your ignition system's manual. I haven't read all the manuals, but read the manual of the ignition system you have. To minimize RFI on an electronic system, we recommend, if you want to minimize the RFI, you want to ground the negative side of the primary, each negative, to have a ground lead, short one, to ground directly to your engine block, just a short cable, grounded to the engine block, every single coil directly to the block. That would give you the maximum reduction in RFI, or minimize RFI. If you don't have so much of a RFI issue, the typical recommendation, as in the manual, is for each bank, you ground the two ends of the bank, the negative to the engine block. So for V engine, you have 4 grounds. If you want maximum reduction in RFI, you ground each coil to the engine block. So further on the proper grounding of the ignition system, again, follow the manual of your ignition system. This is an electronic manual. For example, the NGI 1000 manual, the NGI 1000 ignition controller, the box itself, the case has to be grounded to the engine block. As you can see with where I indicated with a green star, it has to be engine block to tie to the case. The power supply negative must also be grounded to the engine block, and then the whole engine block tied very well to the ground. A side note on engine block grounding: for proper engine grounding, different areas have different requirements, so do check with your local regulation. You must first meet the local regulations for grounding of your equipment. My recommendation is your engine ground electrode, it must go deep enough to touch the groundwater, deep to touch the groundwater. There's a lot of energy from the ignition system that needs to go to the earth ground. This is not so much for RFI reduction or however, but for the general stability and reliability of your ignition system, you should make sure you tie your earth pin all the way to earth ground. It's a lot of energy, several tens of thousands of volts going through each firing. You have to get that energy to the earth ground, really deep down. So tie your ground very well, and you would have a much more stable ignition system. Other factors: always avoid loose connections on the primary and secondary of the coil. Primary meaning your low voltage side. Secondary is your high voltage side. Always, your high tension leads, it should be a very solid connection. Your primary connection should be solid. It should not be shaky. Your high tension leads, firm connection to your spark plugs. If the seals on your high tension leads are worn, you should either replace the seal or replace the whole high tension lead. The high tension leads and plugs should be replaced in the proper intervals in the recommended time. If everything gets old and connections get bad and shaky, all not good. Spark plugs, if they wear out, change them. So after doing all that, I hope you would have a lot less headaches concerning RFI EMI interference on your gas engine. Thank you very much. Goodbye.